I'll record this. Don't let it stop you from asking questions, of course. And we'll see how it goes. I've got the chat window up, but it's also possible that I'll miss it as I'm going through things. So don't be afraid to speak up on somebody else's behalf. And we'll just get going. So just to make sure everybody kind of is on the same page about what to expect this upcoming year. So every year we're given a rule book about things with the robot, what the rules are for the robot. A lot of them can be very similar from year to year, but we always have to go and look at it and make sure that we understand what it is. Some common things to look for are what the maximum starting size is. So typically when the robot starts, everything has to fit within something called the frame perimeter. Not always the case. There have been some games where it's been a little bit different than that. And so there's maximum length, width, and height for the robot for that. And then normally there's a maximum weight for your robot. Lately it's been 125. We have to be careful. Sometimes that includes some bumpers. Sometimes it doesn't include bumpers. And then there's an expansion limit, like how far the robot can expand. Sometimes it's 10 inches in every direction. Sometimes it's 10 inches in one direction at a time. Sometimes you can extend vertically a long, long way. Sometimes you can't. All just things to think about with that. And then some detailed specifications for the control systems and pneumatic system. I'm going to be interested to see how that changes next year, because the new power distribution hub can hold 20 or can power 20 motors, as opposed to the old system was only 16 motors. So it's possible that they may say you can't use all 20 channels of the new power distribution hub. We'll have to see how that goes. And then some safety rules. Oh, go ahead.
So was there a limit on motor count for the 2020-21 game? I thought it was like 12, or am I incorrect in that?
There is a motor limit, but you're more limited by how many channels there were on the power distribution panel, the CTRE one.
And that's why you were, is that why you were like limiting how much motor certain subsystems could use and stuff?
Yeah, so there are 16 channels. And so what we did is we had 2 for each side for the drivetrain. So that's 4 motors there. And then we had the ball tower. And then we had 2 for the shooter, 1 for the hood, 1 to raise the arm, 2 for the intake, and then 1 for the hopper. And so that's, I think, at least 12 there. We wanted 1 more for the control panel, which would be 13. We wanted 1 for the limelight, which was a 14th one. And I think I'm missing 2 others that I just can't think of right now. Oh, climber and traversal. So that covers all 16 motors that we had last year. So even though the limelight's not a motor, it takes up a channel of the power distribution panel.
Okay.
And then there's typically some safety rules. So like you can't use fire or chemicals or things like that. So the robot designs are heavily based on the season they're built. And so as you gain some experience, you can usually end up looking at a robot and know what season it was for just based on that. There are some odd times where a robot from one year can be used to play for another year. But that's pretty rare. So there's a bunch of different things that we can use on a robot. Obviously, one of the more common things that we use are motors. And so I've got some slide decks about each of the different types of motors. And so we can jump into that sometime if y'all want to learn the differences between the motors. But basically, there's different motors. They have different amount of power. They weigh and are physically different sizes. And so you can even just see from here, there's the Neo and the Neo 550. So the Neo 550 is a much smaller motor. And the Neo is even smaller than the Sim over here and weighs less, but the Neo actually gets more power. The Falcon has more power and it actually has a motor controller built into it, which can be good or bad depending on what it is that you're trying to do there. So there's a lot of different things for the different motors, and I'm happy to spend that or spend a presentation on that next week or in the coming weeks if you'll want to learn more about the different motors and how to select which motor it is that you want for your application. For the most part, I'm going to be encouraging that we use brushless motors for everything in the future, which is either a Falcon 500, Neo 550, or a Neo, because these brushless motors have something called an encoder internal to them. So there's already a sensor there, so we can control how many revolutions it spins. Something like the Sim or our old brush motors don't have an integrated encoder, which means that we have to put a sensor external to it if we want to know how fast it's spinning or control the position or anything like that. Sometimes we need to do that anyways, but it's nice having it integrated into the motor. And then we have the electronics for the subsystem, obviously. So the electronics controls all the power to the motors, the electronics and pneumatic controls the solenoids to move pneumatics, which I'll talk about in a minute. And pretty much all the wiring and connectors are what we consider the electronics. So looking at this picture here, you can see we've got the Robo-Rio, which is like the brain of the robot, the computer, the main processor. There's a power distribution hub over here that takes the battery voltage and distributes it to all the motors. There's some motor controllers in here. This is the voltage regulator module, or the VRM, which takes power from the power distribution panel and gives it the Robo-Rio and the radio of power. So all of this stuff on this plywood piece of wood here would be considered the electronics, the connectors between it and everything too. Another way to generate some power is the pneumatic system. And so we don't always have pneumatics on this robot. They can be very useful if you have a mechanism that only needs to be in one of two places. For instance, an arm is a very common place to use pneumatics because the arm is typically either up or down. You can do some fancy things to kind of have 3 positions or multiple positions with pneumatics by ganging them together, or having something that's a hard stop in between that can move to allow it to be pushed into a hard stop that's only halfway through, things like that. And a pneumatic is basically using compressed air to create motion. So in this GIF down here, you can see air is being pushed in to extend it out, and then to retract it, air comes in the other way and pushes it back. And so you can control how strong this is by a mix of different things, either how big the bore is or how much pressure you have it. So the pneumatics that we use, we're only allowed to have a working pressure of 60 PSI, which is pounds per square inch. But we're allowed to store it at 120 PSI. And so this like black tank here that says Clippard, that's where all that air would be stored. But then it gets regulated down to 60. And then this object here is called a solenoid. And that's what directs air either to make the cylinder over here extend, or if air comes in here, it pushes the cylinder back so that it retracts. And then there's a pump over here that fills the tank with air as well. Any questions on anything I've talked about so far? Please feel free to interrupt as I'm going through this. I've got some additional slides about pneumatics, and so that's another thing that I could spend a lot more time talking about. This is just a one-slide thing. I've got 20 some slides that goes more in depth into that as well, if we want to talk about that. Subsystems and subteams are what we typically call the different groups that work on the robot. So we typically don't have somebody that's just working on quote unquote the robot as a whole. They're typically working on a specific subsystem of the robot. And so each of those subsystems are based on the task that the subsystem is trying to do. So for instance, we have a subsystem that's focusing on just making sure that the robot drives. We have a subsystem that focuses on being able to pick up game pieces. We have a subsystem that would be used just for scoring the game pieces or just for climbing, things like that. It's not always, or there aren't always the same subsystems from year to year. It's been numerous years in a row now that we've had a climber subsystem. Very few games don't require a drivetrain or a base subsystem, but there have been a couple of games where you don't need to drive around. You could sit in place and do something from there. Very few teams do that though. Typically you need some kind of intake subsystem and then some kind of scoring subsystem, such as a shooter or an arm or something like that. You'll also hear this referred to as mechanisms. We'll refer to something as like the intake and the arm. Both of those are manipulators because they're manipulating the game piece, things like that. So what Spectrum has is some example subsystems from past FRC robots. So we can look at the drivetrain subsystem here. And so the purpose of it is to allow the robot to move around the field. And it's typically the main robot frame or the frame perimeter. So when you look at it, you'll see a rectangle, and typically all of that rectangle around the bottom of the robot is typically part of the drivetrain. And then it's got wheels and motors and gears, either chain or belt, to power the wheels from the gearboxes. There's also a kit drivetrain. So you'll see a lot of robots end up having a very similar looking drivetrain. It's called the kit parts base, or kit drivetrain. It's also referred to as the AMU or AM1 4U4 is the latest one. There's also an AMU1 4U 321 back to older past years, but the U4 is the newest one. And so teams are eligible to receive that in their kit of parts. And so most teams should use this when they do drivetrain design. We're a large team with enough resources and enough experience that we don't have to use the kit of parts drivetrain. There's absolutely nothing wrong with using it. In fact, if we wanted to just decide to use the kit of parts drivetrain, that's one less decision we have to make, or design that we have to do, and then we could focus more energy onto other things. But there can be some small advantages to designing your own as well. So we typically do a different type of drivetrain that I think we'll talk about in a little bit. So there's different types of drivetrains. Typically, the two that you'll see the most frequent are either a tank or a skid steer. And so this is the standard drivetrain. It's what the kit of parts is. It's what we've done pretty much every year. There's a left set and a right set of wheels that control speed and turning. And you'll sometimes hear the term West Coast drive, and that's just a type of tank drive. West Coast drive just means that the axles for the wheels are cantilevered. So if we look at this picture, you see that there's a piece of metal frame along the outside. And so if you wanted to be able to replace a wheel, it means you need to be able to push that axle through to be able to drop the wheel and put a new wheel in. And West Coast drive, the axle gets supported by two ends of a tube on the inside rail. And so it's cantilevered. So if you want to, you can take off a clip or a shaft collar and pull the wheel off directly. So you don't have to mess with the axle or anything like that. But West Coast drive is also a tank or a skid steer drivetrain type. And so in order to rotate, you would have one side go backwards and one side go forward. And depending on the difference between those, it changes how much you rotate, or obviously you go straight and back, things like that. Another common type is swerve. This is a more advanced drivetrain, although it's becoming more and more a COTS product, meaning commercial off the shelf. So we can go and buy a swerve module for $400, but we need 4 of them. So that's now $1,600. And really, we end up needing 2 sets of that, one for a practice robot, one for a competition robot, probably 2.5 sets because we want some spares. So obviously that starts getting expensive to go buy swerve modules. So the neat thing about swerve, though, is that one motor controls the direction of the wheel and one motor controls the speed of the wheel. So if you can imagine this blue tread down here, it can spin in a circle. And so the wheel can be facing any direction. And so it allows for your robot to strafe side to side. It can go forward while spinning. It can do all sorts of neat things. And you can always have your wheels facing in whatever direction you're pushing. So you can have the maximum amount of driving force in any direction. So you definitely see some teams do swerve. It gives some teams a competitive advantage. If you aren't quite there yet with swerve, if you don't have drivetrain practice, or if you don't have driver practice driving with swerve, if you don't have some prior experience with swerve, it can be a disadvantage because you spend a lot of resources, time, money, experience, and all that trying to get swerve working, and you miss out on your other mechanisms. But it is definitely something that's a lot of fun to watch. So we might pull up a video for that later. There's also Mecanum wheels and Omni drivetrains. So Mecanums have these rollers at an angle. If you've done FTC, you're probably very familiar with Mecanum wheels. And so this also allows you to drive side to side with only needing 4 motors as opposed to 8 motors for swerve. But it's really not great for FRC robots. I highly discourage this for any of our FRC robots. You don't get good traction, so you're a little bit easier to push around. It's also going to be something that other teams will kind of judge you for doing. So we would have to be really good, I think, so that other teams don't judge us for doing Mecanum. It's just easier to defend a robot with Mecanum wheels than tank drive or anything like that. And oftentimes I find that you're just not very quick at strafing, or you don't use the strafing ability as much as you should. You just drive it as if it were tank steer anyways. There's also this Omni or X-Drive or Kiwi. Kiwi just has 3 wheels as opposed to X-Drive having 4 wheels. So Omni wheels have rollers at 90 degrees to the wheel itself. So that's something then that can, the X-Drive and Kiwi can give you omnidirectional drive. So you can drive left or right and forward and backwards and rotate. But again, you're limited to with traction and pushing power. If you're going with a drive like this, you're just accepting that anyone's going to be able to push you around. There can be some advantages to having all Omni wheels, because if somebody tries to pin you, they just push you to the side, and so you can try to pirouette out of it or spin out of it. But again, that's something that you really need good drivetrain practice to be able to do. Again, anyone can interrupt me at any time if you want. Some more advanced, or I don't know, some other advanced types are this H-drive one. So basically your wheels make up an H here. So you've got 4 motors that allow you to drive back and forth. And then you've got put a fifth motor or fifth wheel in this horizontal orientation. And so it can strafe sideways, just doesn't have as much power as it does forward and backwards. I've also seen designs where it's normally up and then it comes down, or pushes things down, or combination articulating, which is really what this is, where you're able to change between 2 different drive tanks, drivetrain styles. So for instance, we did something similar to this picture here. This is sometimes referred to as butterfly drive. Basically, we had pneumatics that would push down Mecanum wheels, and then if we let the pneumatics lift up, then the traction wheels would be touching. So we could have the benefits of traction or the benefits of Mecanum. And it just costs us weight to be able to put the pneumatics, have 2 sets of wheels, and the complications from that. I still don't recommend it. I wish that we hadn't done that in 2017, but that's what we did. Any questions about the drivetrain types before I go on to the next thing? Okie dokie. So another thing is that all robots need to have bumpers. And so bumpers are what protect the robot from damage. If you look back at robots before, I think 2005 or 2006 is when bumpers were added. There were no bumpers. And so drivetrain frames, could get bent up really bad. And with all the power that there is in motors nowadays and how much power people put into the drivetrains, yeah, it's a lot of, you could do a lot of damage. So these bumpers absorb a lot of the impacts for robot to robot interactions. It's made of plywood and then 2 pool noodles and then some fabric going around it. It's also very useful because you can tell which alliance a team is on. So you have a red alliance and a blue alliance, and it has your team number on it. So I think bumpers were a good addition to FRC. It is something that we often don't think about until too late in the game. And we should try to do a better job of thinking about how are we going to mount our bumpers to our robot and plan for that ahead of time and have some people working on it so that they look good. A good set of bumpers can make your robot look better than it is, and a bad set of bumpers can make your robot look worse than it is. So it is something that we always put together at the last minute and we always struggle with. They come out okay, but it'd be really nice if we took some time and made them good earlier. All right, so there's a couple different types of intakes we're going to talk about. The first one is a floor intake. And so it's really useful. And I think it's something that generally speaking, we want to do. There have been a few years where you don't need to have a floor intake to be very good. And in fact, that's a good case study from the 2011 game, is looking at a team that decided they weren't going to do a floor intake because it made their robot a lot simpler and they got to practice a lot more, and they ended up having one of their best years ever. And and made it very far in the playoffs at the World Championship level, despite not having a floor intake. And so typically what happens is you have an arm that comes down, and then there's rollers or wheels that spin to collect the game piece into the robot. It's been a long time since I've seen a game piece where using rollers or wheels is not the right solution for taking in a game piece. Sometimes a lot of people want to think about like a pinchers or a claw or something like that. But when the robots are moving really fast and the robot is really far away, you don't want that precision aspect needed of being able to pinch on things. So the rollers or the wheels allow for a phrase that you'll hear sometimes called touch it, own it. So ideally, as soon as your robot touches a game piece, nobody else is able to take it from you, and it comes into your robot just from touching it. Doesn't matter what angle you're at or anything like that. You want it as soon as that intake touches that game piece, you know that it is yours. There's also human feeder intakes. And so in most games, there's a station where you can intake a game piece from a loading area and secure it into the robot. It's not always the case, but that is pretty common. And so 2017 is actually one of the years that I can think of in particular where you really did not need to have a floor intake for the gears. Most teams took it from the loading station. And that made the design very easy because it's easy to have that game piece just fall and drop into your intake. And so Liam, great question. You aren't informed what the game pieces are before the kickoff time period. So kickoff is, I think, like January 7th this year or something like that. And that's when we find out what the game piece is. And then we'll have those 6 weeks or really more like 7 or 8 now without the bag to design our robot and figure out do we want a floor intake, only use a human feeder intake, etc. And so, yeah, so a human feeder intake is usually useful because it reduces the complexity for the intake significantly. But it can be bad if it slows down your whole process a lot. The 2017 gears was an exception to that rule just because in 2017, you typically had to cross the field to get the game piece anyways. Sorry, lost where I'm at here. And I'm getting enough, my puppy's getting upset too. All right, so the next thing here is a hopper or an indexer. You don't necessarily always have to have something like this, but typically there's some part of your robot where the game piece is between the intake and scoring the intake. In 2017, for instance, with that gear intake, that wasn't true. Your intake was also where the game piece was stored and also where it was scored from. But for something like the 2020 game here with these yellow balls, the intake brought in the balls and then they got stored in a separate location before they were shot out or launched out the game. So a hopper or an indexer is typically used in short shooting games. There are a couple of instances where you might see it in pick and place type games, but not as often. A wheeled launcher is a very common way for any time that there's a ball. Sometimes the rules explicitly state that you can't launch game pieces. But I mean, basically you just have a wheel. Sometimes it's a wheel on both sides of it. Sometimes the other side is just something smooth that gives it a curve that follows so you can control the trajectory of it. And so it's definitely something that you see pretty frequently. Another common launching mechanism is a catapult. It's useful when you only have one game piece that you're trying to score at a time. So some games like 2014 and 2016, you are only allowed to have one game piece. And so a catapult is nice because a flywheel, the compression changes how much your robot or how far the ball is shot. And so from ball to ball, you'll get some variance in how firm that ball is, or if it might start to wear out or something like that. So you can take some 2020 game pieces and a brand new one is really firm and an old one is really torn and compresses really easily. So they shoot differently. But with a catapult, that game piece doesn't matter as much and it shoots more consistently with a catapult. But in 2020, we had 5 game pieces we were trying to score at once, so a catapult was not the right solution for it. But 2014 and 2016 were 2 games where you just had one, so a catapult was a great solution for it. Another common scoring mechanism is an elevator. We actually haven't really done an elevator. We kind of did in 2015. It was a very small elevator, but you guys know what an elevator is. It just goes straight up and down like a forklift, and it's used to score objects up higher locations. A lot of teams use elevators in 2018 and 2019. And then, like I said, we did not. We ended up using an arm, which is the next slide. And so an arm just raises part of the robot in rotation. And so you can see this particular arm that they have, it just raises up and down. This was a very complex arm. And if you talk to Spectrum, they'll tell you that they would never design this arm again. But we've used some arms just because they can be very simple to design. You've got one joint to worry about. And we were able to make an arm that fit our game strategy for both 2018 and 2019. When you get really more complicated, you might have a wrist. And so sometimes a wrist is something that it's like a mini arm, right? And so sometimes teams will have a wrist at the end of an arm. I would generally recommend against it. It looks like Spectrum maybe uses it if it's like just a small thing for like the intake. I would just consider that still basically an arm. But you're rotating around a point. And then there's climbers. So this is something that, you can talk to Jared and Colton, and they're very excited to talk about climbers. It's to raise your robot normally for an end game task. There's been a lot of years in recent years where if you're hanging off the ground at the end of the game, you get some bonus points for it. And so they typically take the form in an elevator. Our climber in 2020 and no, it was really just 2020. Our climber in 2020 was an elevator. Our climber in 2019 was wacky. I honestly don't even know what I would categorize it as. It was a flipper. We basically flipped our robot onto something to climb up it. And then in 2018, we used our arm to hook on some rope, and then we just used a winch to lift up our robot in 2018, and same with 2017. So you can see that, yeah, another common solution is using a winch and a hook to pull a robot up. And so if you've got something hooked around and then just a big drum that spins and winches the robot up on that rope. And then something that we don't see as often is a field manipulator. So sometimes the field has something to interact with, either to release some game pieces or to score some things. And so some examples are that in 2012, there was a bridge that you could push down to be able to climb over to the other side. 2016 was probably the year that I think had the most field manipulators across robots to be able to cross different defenses. And so there were different things that you might do to be able to cross a barrier. And then 2020 had a control panel, but not too many teams did that this past year. But there was basically a big, we would joke and call it the Wheel of Fortune or a DJ booth. And it was just something you could go up to and spin, but only at certain points of the game. So a mechanism library. Spectrum has a photo library of a bunch of different mechanisms. This is really useful. And so if you want to go and look at some different mechanisms, Spectrum has a lot there. And so I am not afraid to tell you to go look at their stuff. They've got some great stuff. So you can go and see they've got robot mechanisms from different years. So if you want to see how did teams accomplish something in 2016, you can go and look at robots from 2016 and look at different catapults. And so they've gone through and they've tagged pictures of robots with catapults. Sometimes, you'll have more or less to be able to look at it. Let's go and look at, let's look at 2020, since hopefully most of you are familiar with that game. And we could look at intakes, and they'll have a lot of pictures of different robots' intakes. And so sometimes you can try to look at it and try to understand what's going on with their intake. So for instance, this one, they just had a gap and then some wheels. So they would drive in and hopefully this gap wasn't enough to bounce balls away. These wheels would grab some and then index it into their hopper area. So this is just some different tags that they've got: electronics, drivetrain, intake, hopper, wrists, and launcher. I think this is just one of their individual albums here. I think maybe that they're even like looking at this specific robot. What are some things that you can see on it? So it looks like I see a climber here. You can definitely see some information on their drivetrain. It's kind of interesting that their drivetrain has these handles. That's neat. That might be worth looking about. You can see a little bit of their intake over here, and then a little bit with their hopper too. So, but it's probably not a great picture for their shooter because you can't see very many details about what's going on with their shooter. And so, yeah, it looks like maybe this was just them doing an exercise to discuss what they would tag in the robot. So, yeah, so that is Spectrum's overview of FRC robots. What did you guys think of that? Is that something that you guys want to continue to do from year to year? From week to week, pick different training slides, or I could go over some more now. We have about another 20 minutes. I'm happy to go more in depth into motors or pneumatics or something else if you guys want.
You said something about like videos. Could you show some of the videos?
Yeah, just to make sure, are you talking about like the videos from Spectrum's mechanism library or videos from something else? I'm not sure when I was mentioning the videos.
Just any videos would be fine.
Okay. Anybody else have anything else while I'm looking up some videos? All right, let me share a screen and let me go through the slide deck real quick just to see if there's anything in particular that I was thinking maybe some good videos for. Yeah, let's, oh, you know what? I think, where's, do I have the history of some games? Because we went through a bunch of past games and I thought that we had some neat videos to share there. Let me see if I can find that. Sam, do you remember that? Was that something that you think would be valuable? Okay. This isn't it. Well, now I can't find it. Okay, well, we'll just go through. I'll optimize for video sharing real quick. And we'll do Robonauts. We'll just look at a bunch of Robonauts videos because their reveal videos are always the best. And so let's even just go to my favorite one. So you guys can all see this okay, right?
Yes.
Okay, so this is the 2013 game. And so what you'll see is that the game was to pick up and shoot Frisbees. And there's also a pyramid that you could climb at the end. And so we're gonna watch a video. I'm even gonna let it play with the sound just because it's so great. It's my favorite. Hopefully I can talk and you guys can hear it and the video is not too loud. So I'll explain some things as we go through here. So you can see that they have a floor intake where they're picking up Frisbees from the floor. They have a launcher. That's still a flywheel launcher. It's just on its side. They have a hopper in there that's basically a bucket where those Frisbees get stored. And their drivetrain there was an 8-wheel drivetrain. Shine So the key thing that they did that was really special that year, and some other teams obviously did it as well, was what was called a full court shooter. So this robot and a lot of the best robots in the world were able to shoot the full length of the field, which is what they'll show in a second, where basically they would park up against the wall, and if you left them alone, they would just continually shoot and make these 3-point scores right up here. Something that was kind of interesting is that there was this pyramid that you had to climb sequentially to get up to the top. So if you were hanging from the bottom rung, you would get 10 points. From the middle rung was 20, and from the top was 30 points. And so what basically teams did is they did a trade study type deal and said, hey, we can climb on at the last second and get 10 points, but how long is it going to take us to climb up to the top to get 30? And scoring 30 points was scoring 10 frisbees. And so a lot of teams decided that they could score enough frisbees and quickly just hang from the bottom rung quicker than they could climb to the top. So this was Robonauts' efforts at climbing up the side of the pyramid to be able to get the 30 points from climbing it. They ended up never using it in competition because it was just too slow. It wasn't an advantage for them. But it was, I think, still a really cool mechanism to be able to watch. So I love watching that go. Let's see if I can get to where they're, here we go. So this is where they're doing their full court shots. So you can see this is now their human loader station. So they don't need a floor intake for this. And they just sit there and have their human player dump frisbees in, and the robot shoots it, and they're just making shot after shot. And so some other teams did this as well very successfully. And so that would be a good example. If you went with a full court shooter only, you only need the human loading. Or if you're just willing to drive all the way back there to drive up and shoot. Let's look at another year. So their 2018, they have a shot of their drivetrain that might be good to pause and talk about real quick. Oh my gosh, this ad's taking so long. So 2018 was I'm sorry, not 2018. I'm thinking of 2014. 2018 is a fun video too. So 2018 was a year that we had a big yoga ball as the game piece. And so they went with a, you would call this more of a puncher than a catapult, but essentially a catapult. There's this big spring that had, 100 some pounds of force or something to be able to launch the game piece. But the cool thing that they have with their drivetrain that we'll be able to see a little bit is they had an articulating one so that they could drop some omni wheels so they could rotate around very quickly. They didn't use it a whole lot, but you can kind of see it in work there. That was really hard to see. Basically what they do is they have some omni wheels in the back here. So they keep their traction here, and then they lift with their omni wheels, which allows them to rotate around the front of their robot. So they really pivot around the front of the robot instead, which is pretty cool.
Is there a way I can access this video?
What's that?
Is there a way I can access this video?
Yeah, absolutely. All you got to do is search for Robonauts on YouTube. So searching for Robonauts or Robonauts FRC, you'll find Justin Ridley. Yeah, they're really great robots. They're one of our main, I don't know, I don't even want to call them rivals because we're not good enough to be their rival or anything. They're a really great robot. Or a really great robotic scene. They help us out a lot too. Oh, this is saying, are you guys able to see this?
Yeah.
Yes.
Okay. I was getting a weird, something's in the way of it. Here's the 2020 or their 2020 robot. Actually, you know what? Let's show the 2017 because that one's better. 2020, they have a really fast shooter, but their 2017 robot shot balls so quickly. So in 2017, you could hold as many balls as you could in your volume. They had a goal of making sure they could hold 118 balls because, of course, so I was hoping to just show the shooter here. So you can see they're collecting all the balls with their floor intake. And you can see that they've got the type of situation where their intake's just right at the edge of their gap. They don't have an intake arm come down or anything. They've got a turret for their shooter. So you can see that their shooter is just so many balls so quickly. Truly insane to me how quickly they shot. But the thing that was weird about this year is shooting balls was not the main way to win a game. You basically only got 1/9 of 1 point per ball. So you really have to shoot at an insane speed and use a lot of balls to get worthwhile points. Meanwhile, the gears, you were getting like 30 points per set that you completed or something like that. So the gears were definitely the main way to go. So we're coming up with about 10 minutes left. I forget who asked that. Was that Iris? Was that kind of what you were hoping for, or were you wanting to look at other videos?
I think it was fine.
If there's something else that you're looking for, definitely, let me know.
Maybe like more educational.
Okay. So yeah, let me show you where some educational videos are. So actually, I'm going to just promote Spectrum's training. When Alan Gregory, their coach, goes through it, they've got video of it too. So if you wanted to go through basically some slides and have somebody like me that is going through them in a video, again, training.spectrum3847.org. So these videos are going to be Alan talking about things and going through their robot, but it's nice. He's got a lot of them done. Another good place if you want to do Onshape stuff, if you want to do CAD design, if you sign in, let me do that. I screwed that up. Oh my gosh. If you go to the Learning Center of Onshape in that top right-hand corner up here, and go to the self-paced courses and learning pathways, there's some really good things here. So under the learning pathways, there's this CAD basics and Onshape fundamentals. Honestly, I can't recommend enough the Onshape fundamentals and the CAD basics completing these courses. These are really cool. They've got a couple of slides. Are you supposed to
be sharing your screen?
Oh, I am supposed to be sharing it. I'm sorry. Let me fix that. This guy. Let me start with back here with Spectrum. So training.spectrum3847.org. You can see all their training curriculum here, and that Alan's got videos of him going through the training. And honestly, these are great things to take a look at. But then in Onshape, if you log in, there's the Learning Center in the top right-hand corner. And then under self-paced courses, learning pathways, there's CAD basics and Onshape fundamentals. Both of those are really just super great. So if you do the CAD basics, there's this here, and you can do the view course. And basically, like, you'll go through, let me start with the beginning here. So there's a video here, and
allowing engineers to visualize
CAD. And if you want to be able to listen and read, or if you need to read and just have it being read to you at the same time, there's a transcript here as well. And there's little places along the way where you can kind of self-check. So, this one actually is, I think, a little tough for some people. And so don't feel bad if you struggle with this, but it says which 3D object would result in folding which 3D object results in folding the development around the gray face. So you've got this square here. So you'd have to imagine, okay, I'm folding up these two things. So we know we're going to have a ramp there and this is going to be 2 square edges. And so we'd have to go think about what is that going to end up looking like. And that can be definitely a challenge at times. Like I'm even having a hard time thinking about it right now, but we know it's going to have a square base. We know it's not going to be this C one here because there's nothing indicating like that. Same with D. I don't think it would be E because that would have to be 2 squares this direction and just the 2 triangles on the side. So I think it's going to be B because we have 2 triangles on the side, 2 triangles here, and then 1, 2, 3 squares. So we would go and select B and say next question. And it lets us know if we get it wrong. So let's see. Whoops. If I go back to the self-check, let's see what happens if I select D. Nope, I guess it tells me later that I got it wrong or something. So anyways, I think that this is all good things to do. The CAD basics is probably a little bit harder than I would like it to be, but you can also go back to the home, and the on-shape fundamentals is really great. And I just need to figure out how to, there's part design using Part Studio's introduction to sketching. So if you want to get better at sketching, this is really good. And these are good videos for it too. All right, well, any questions before we end here today?
Nope.
All right, is this good? Is this something you guys want to do again next week? Is 7 o'clock good? Would you guys prefer that we do it later?
It's good.
I think it's good at 7 o'clock.
Okay. And last question, is there anything that you guys think you want to go more in depth into next week? Do you guys want me to talk about more about motors or pneumatics or a certain type of manipulator or bases or anything like that?
Maybe you could I guess show it in design, because I kind of want to see the like the application.
Okay, I don't know that I quite, can you state that again, maybe differently? I don't quite follow. I'm also going to stop recording.